Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the area of the blue shape. In the second question, we'll find out the radius of this circle that blocks triangle ABC. So we'll start with the first question. In the drawing, we have the big circle that blocks triangle ABC. We know that AB is the diameter of the big circle, and we know that the radius of the big circle equals to 14 units, and triangle ABC blocks the small circle, or the small circle is inscribed by triangle ABC, and we know that the radius of the small circle equals to 4 units, and we want to find out the area of the blue shape. So first of all, we will define the radius, we will define the center of the small circle as O. We will define the point of tendency of tangent CB with the small circle as M. We will define the point of tendency of tangent AC with the small circle as N. And we will define the point of tendency of tangent AB with the small circle as L. In the next step, we will join points O and M together by a straight line. O is the center of the small circle. M is a point on the small circle itself. And this is exactly the definition of a radius. So OM is the radius of the small circle that is equal to 4 units. So we will define the radius of the small circle as small r, and you know that small r equals to 4 units according to what is given as the question. In the next step we join points O and N together by a straight line. Again, O is the center of the small circle, N is the point on the small circle itself. Therefore, ON is the radius of the small circle that is equal to 4 units. And we also have rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I repeat again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have radius OM that is drawn to the point of tendency, that is to say the radius OM it is drawn to point M, that is the point of tendency of tangent CB with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius ON that is drawn to the point of tendency, that is to say the radius ON it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent CA will be perpendicular to the radius NO. So CA is perpendicular to NO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. And we also have the rule that any peripheral angles that rest on the diameter of a circle is equal to 90 degrees. So if peripheral angle ACB, this angle ACB rests on the diameter of this circle that is AB, Therefore, it is equal to 90 degrees according to the rule that I mentioned. So angle ACB also equals to 90 degrees. So actually we found out that in quadrilateral LNCM we have 1, 2, 3 right angles. In quadrilateral ONCM, this quadrilateral, we have 1, 2, 3 right angles. Okay, I'll write it down. In quadrilateral ONCM, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MON, this angle. In total, the sum of those 3 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle MON is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. Okay, so this angle is a right angle, it is equal to 90 degrees. So I actually found out that inside quadrilateral ONCM we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral ONCM as a rectangle. Quadrilateral ONCM is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, NO equals to CM. NO equals to CM, according to the rule that the opposite sides of a rectangle are equal to each other. But we already found out that NO equals to 4 units. It is the radius of the circle, of the small circle. So NO equals to 4 units. And from this equation, 4 equals to NO equals to CM. We will derive that CM is also equals to 4 units. CM equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we'll get that OM equals to NC. OM equals to NC, according to the rule that the opposite sides of a rectangle are equal to each other. But we've already found out that OM equals to 4 units, so we can write here that OM equals to 4 units, and from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. Okay, NC equals to 4 units. So we actually found out that all the sides of quadrilateral ONCM are equal to each other, therefore quadrilateral ONCM it is not a rectangle but a square. Okay. In the next step, we'll define side AC of triangle ABC as A. So here, side AC equals to A units according to our definition. We define side BC as B. BC equals to B units according to our definition. And we define side AB as C. AB, that is the diameter of the base circle, equals to C according to our definition. Okay. I repeat again. AB equals to A, BC equals to B, and here for it is AC, AC equals to A, BC equals to B, and AB equals to C according to our definition. Okay? In the next step we will find out the length of AN. What is the length of line segment AN? From the drawing it is very easy to see that the length of line segment AN equals to AC minus NC. Repeat again, the length of line segment AN is AC minus NC. So AN equals to AC. AC is A according to our definition, minus NC. NC equals to 4 units according to what we have already found out. So in conclusion, we found out that AN equals to A minus 4. AN equals to A minus 4. Likewise, we find out the length of line segment MB. From the drawing, it is very easy to see that the length of line segment MB is equal to CB minus CM. Again, CB minus CM. CB minus CM equals to MB. Repeat again, MB equals to CB minus CM. So MB equals to CB equals to B according to our definition, and CM equals to 4 according to what we have already found out. So in conclusion, we found out that MB equals to B minus 4. Here MB equals to B minus 4, so we found out that MB equals to B minus 4 and AN equals to A minus 4. Okay, in the next step I will present to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again on rule number 2, the lengths of two tangents from a common external point to a circle are equal. So we focus on the common external point, point A. From the common external point, point A, we have two tangents to the small circle. The first tangent is tangent AL, and the second tangent is tangent AN. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, AL equals to AN according to rule number 2. Okay? AN equals to AN according to rule number 2. But we have already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation, AN equals to A n equals to a minus 4, we will derive that AL is also equals to a minus 4. AL is also equals to a minus 4. Here, AL equals to a minus 4. Okay. Likewise, we find out, we'll focus on the common external point B. From the common external point B, we have two tangents to the small circle. The first tangent to the small circle is BL and the second tangent is BM. And according to rule number 2, they are equal to each other. That is to say, BL equals to BM according to rule number 2. But we already found out that BM equals to B minus 4. So we can write here that BM equals to B minus 4. And from this equation, BL equals to BM equals to B minus 4, we will derive that BL is also equals to B minus 4. BL is also equals to B minus 4. BL equals to B minus 4. So in conclusion, we found out that BL equals to B minus 4 and AL equals to B minus 4, or AL equals to A minus 4. So we know that AB is the diameter of the big circle. So AB as the diameter of the big circle is twice as long as the radius. So if the radius of the big circle equals to capital R, then AB must be equal to 2 times capital R. It is given us the question that capital R equals to 13 units, so therefore 2 times 13 is 26. So AB, the diameter of the big circle, equals to 26 units from one side, but from the other side from the drawing it is very easy to see that AB equals to AL plus LB. AB equals to AL plus LB. So AB equals to AL plus LB. Hopefully, what is the question number 1? AL equals to A minus 4. And LB equals to B minus 4. So in conclusion, according to equation number 1, we found out that 26 is equal to AB equals to A minus 4 plus B minus 4. So 26 equals to a plus b, minus 4 plus minus 4 is minus 8. 26 equals to a plus b minus 8. Here we will add to this equation 8. And we will get that according to equation number 1. 26 plus 8 is 34. That is equal to a plus b according to equation number 1. Here we will square both sides of equation number 1. And we will get that according to equation number 1, a plus b squared equals to 34 squared. We'll open the brackets on both sides of this equation number 1, and we'll get that according to equation number 1, a plus b squared equals to a squared plus b squared plus 2 times ab, and it is equal to 34 squared. 34 squared equals to 1156. So according to equation number 1, we found out that a squared plus b squared plus 2 times ab equals to 1156. In the next step, we will focus on the right triangle ABC. On the right triangle ABC, according to the Pythagoras theorem, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here, by PT is the abbreviation for Pythagoras theorem. The hypotenuse is AB, so the square of the hypotenuse is AB squared. That is equal to AC squared plus CB squared. So actually, according to equation number 2, we found out that AB squared equals to AC squared plus CB squared. We have already found out that the hypotenuse, that the diameter of the circle it is equal to 26 units. So C equals to 26. C equals to AB equals to 26. So AB squared is 26 squared, and 26 squared is 676. That is equal to AC squared. AC is A, so AC squared is A squared, plus CB squared. CB is B, so CB squared is B squared. So in conclusion, we found out that according to equation number 2, a squared plus b squared equals to 600 76. This is according to equation number 2. And because of the fact that a square plus b square equals to 676, it means that we can substitute a square plus b square in this equation number 1 by 676. Okay, so we do it now. We will get that according to equation number 1, a square plus b square equals to 676. Plus 2 times AB equals to 1156. So here we'll subtract 676 from this equation number 1. And we get that according to equation number 1, 2 times AB equals to 1156 minus 676 is 480. So according to equation number 1, we found out that 2 times AB equals to 480. Here we divide this equation number 1 by 2, and we will get that A times B equals to 480 over 2 is 240. So we know that AB equals to 240. We divide this equation number 1 by 2 again, and we'll get that according to equation number 1, A times B over 2 equals to 240 over 2 is 120. So we found out that according to equation number 1, A times B over 2 equals to 120. So what is the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape and the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. I repeat again. From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So it is equal to the area of triangle ABC. The area of triangle ABC equals to the base AC times the height to the base, that is CB, over 2. Okay, the area of triangle ABC equals to the base AC times the height to the base, that is CB, over 2, minus the area of the small circle. The area of the small circle equals to pi r squared. When r equals to 4 units, it is the radius of the small circle. So in conclusion, we found out that the area of the blue shape equals to the area of triangle ABC, that is AC times CB over 2, minus the area of the small circle, that is pi r square. So it is actually equals to AC is A, according to our definition, times CB is B, according to our definition, over 2. So the area of triangle ABC equals to A times B over 2 minus pi r square. R equals to 4, so r squared is 4 squared, that is 16. So here the area of the small circle in conclusion equals to 16 pi. So it is AB over 2 minus 16 pi. We have already found out that AB over 2 equals to 120, so we can substitute AB over 2 by 120. So it is 120 minus 16 pi square units. Or we can present it also as 69.73 square units. I repeat again, the area of the blue shape, the area of this blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. So we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in 3 different methods. Okay. So here in the drawing we have this circle. Triangle ABC is inscribed by this circle, and we know that the area of triangle ABC equals to 9 square units. Side AB of triangle ABC equals to 5 units, side BC equals to 6 units, and we want to find the radius of this circle that blocks triangle ABC. We will start with the first method. In the first method, from point A, we will draw perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and BC as D. So actually we know that the area of triangle ABC equals to 9 square units. So I write it down. The area of triangle ABC equals to 9 square units. But the area of triangle ABC also equals to the base of the triangle, that is BC, times the height to the base, that is AD, over 2. I repeat again, the area of triangle ABC also equals to the base BC times the height to the base, that is AD, over 2. So here the area of triangle ABC, that is equal to 9 units, equals to BC, that is the base BC equals to 6 units, times AD over 2. So according to equation number 1, we found out that 9 equals to 6 over 2 is 3. 9 equals to 3 AD. Here we divide this equation by 3, equation number 1 by 3. And we get that according to equation number 1, AD equals to 3 units. So here AD equals to 3 units. In the next step, we'll focus on the right triangle, triangle ABD. In the right triangle, triangle ABD, by PT is a relation of by Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, therefore the square of the hypotenuse is AB squared. That is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD squared plus BD squared. Okay, so in the right triangle in BD, according to the Pythagoras theorem, we found out that AB squared equals to AD squared plus BD squared. So actually, AB equals to 5 units, so AB squared is 5 squared, that is 25. That is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus BD squared. So here, we subtract 9 from this equation, equation number 2, and we get that according to equation number 2, 25 minus 9 is 16, equals to BD squared. Here we take out of this equation, equation number 2, and we get that according to equation number 2, BD equals to the square root of 16, that is 4. So BD equals to 4 units. So now that BD equals to 4 units. Here BD equals to 4 units. So what is the length of line segment DC? From the drawing it is very easy to see that DC equals to BC minus BD. BC minus BD. DC equals to BC minus BD. So DC equals to BC, that is 6 units, minus BD, that is 4. So in conclusion, DC equals to 6 minus 4, that is 2. So DC equals to 2 units. Can write down here that DC equals to 2 units. In the next step, we will focus on the right triangle, triangle ADC. triangle ADC by PT, the version for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the square of the hypotenuse is AC squared. It is equal to DC squared plus AD squared. So according to the Pythagoras theorem, on the right triangle ADC, AC squared equals to D squared, C squared plus AD squared. So AC squared equals to DC squared. DC equals to 2, so DC squared is 2 squared, that is 4, plus AD squared. AD equals to 3, so the AD squared is 3 squared, that is 9. So in conclusion, we found out that AC squared equals to 4 plus 9, that is 13. You take out of this equation, we will find out that AC equals to the square root of 13 units. AC equals to the square root of 13 units. And write down here that AC equals to the square root of 13 units. In the next step, we will define the center of this circle as O, and we will join the points A and O together by a straight line. In the next step, we will extend side AD by a straight line until it touches the circle, and we will define the touching point of the extended line segment AO in the circle as E. Here, line segment AE or chord AE passes for the center of the circle, that is to say it passes for point O, that is the center of the circle. Any line segment, any chord that passes for the center of the circle is defined as the diameter of the circle. So AE is the diameter of the circle. And the diameter of any circle is always twice as long as the radius. So if the radius of this circle is equal to capital R, then the diameter AE will be equal to twice as long, that is to say it will be equal to 2 times capital R. Okay. In the next step, we join points B and E together by a straight line. Actually, we created here the peripheral angle ABE. The peripheral angle ABE rests on AE, that is the diameter of this circle, and any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Therefore, peripheral angle ABE equals to 90 degrees. Because it rests on the diameter of the circle. Okay, and we also have another rule that states that peripheral angles that rest on the same diameter, on the same chord, are equal to each other. Repeat again, peripheral angles that rest on the same chord are equal to each other. So here we have, if you focus on chord AB, here we have angle ACB. This angle ACB, rests on chord AB, and we have also angle AEB that also rests on chord AB. So those two angles are both rest on the same chord called AB, therefore according to the rule that I mentioned, they must be equal to each other. Okay, so I write it down. Verify angle ACB must be equal to peripheral angle AEB. Because of the fact that they both rest on the same chord called AB. I repeat again. Peripheral angle ACB equals to peripheral angle AEB because of the fact that they both rest on the same chord called AB. So if we define angle AEB as theta, here angle AEB equals to theta according to our definition, then from this equation angle ACB equals to angle AB equals to theta, we derive that angle ACB is also equals to theta. Angle ACB equals to theta. So here we can write down that angle ACB also equals to theta. So in the right triangle ADC, angle ADC equals to 90 degrees, angle ACD equals to theta. So this angle DAC must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle ADC. This angle must be equal to 90 degrees minus theta. And then we'll get that 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees equals to 120 degrees. Okay, so in triangle ABE also this angle equals to theta, this angle equals to 90 degrees. So this angle must be equal to 90 degrees minus theta for the same reason. Okay. So in the next step we'll prove that the right triangle ABE is similar to the right triangle ADC. Okay. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So I write it down. So triangle A, we focus on triangle AEB. This right triangle and triangle ADC. And we will prove that those two right triangles are similar to each other. Alright, they are similar to each other. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle ABE equals to angle ADC, and they are both equal to 90 degrees. I'll repeat again. Angle ABE equals to angle ADC, and they are both equal to 90 degrees. In addition, Those two angles are both equal to theta, therefore they are equal to each other. So angle AEB angle AEB equals to angle DCA angle AB equals to angle ACD, and they are both equal to theta, therefore they are equal to each other. Repeat again. Angle AB equals to angle ACB, and they are both equal to theta. Finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, angle ABE equals to angle BAE, this angle, equals to this angle, this is actually angle DAC, and they're both equal to 90 degrees minus theta, therefore they're equal to each other. Repeat again, angle BAE equals to angle DAC, and they're both equal to 90 degrees, therefore they're equal to each other. So we actually proved that all three angles in triangle AB can go into all three angles in triangle ADC, therefore triangle AEB is similar, this is the sign of similar to triangle ADC according to angle similarity rule. And from the fact that those two right-hand triangles are similar to each other, we conclude that the following equation is true. That AB over AD equals to AE over AC. I'll repeat again. We conclude that AB over AD equals to AE over AC. So here AB equals to 5 units, AD equals to 3 units, AE equals to 2R, it is the diameter of the circle, and AC equals to the square root of 13 units. So in conclusion, we found out that according to equation number 3, 3 over 5 over 3 equals to 2R times square root of 14 units. Here we multiply this equation number 3 by square root of 14 units. And we get that according to to equation number 3. Five over 3 times square root of 13 units equals to 2r. Here we divide this equation number 3 by 2, and we get that the radius that we are looking for, r, equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Finished with the first method. In the next step, I will present to you how to find out the radius of this circle that belongs to ABC according to the second method. In the second method, we will use all the things that we already found out in the first method. Here from point A, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. We've already found out that AD, according to the first method, that AD equals to 3 units, DC equals to 2 units, and BD equals to 4 units. We'll extend line segment AD by a straight line until it touches the circle, and we'll define the touching point of the extended line segment AD and the circle as point E. According to the rule that the sum of the angles on one side of a straight line equals to 180 degrees, this angle must be also equal to 90 degrees. Here, AD is a straight line. Okay, AD is perpendicular. AD is perpendicular to BC, so it is absolutely a straight line. Then we extended the straight line AD by straight line, and when we extend the straight line by straight line, the result, that is AE, must be also a straight line. So, and we know that the sum of the angles on one side of the straight line is equal to 180 degrees, so if we focus on this side of the straight line AE at point D, then the sum of angles must be equal to 180 degrees. So, if this angle equals to 90 degrees, this angle must be also equal to 90 degrees in order to complete the sum of the angles at point D to 180 degrees. This angle must be also equal to 90 degrees. And if we focus on this side of the straight line AE, here the sum of the angles at point D at this side of AE must be equal to 180 degrees. So if this angle equals to 90 degrees, this angle must be also equal to 90 degrees, because it must complete the sum of the angles to 180 degrees. Okay. The next step, I present to you rule number 1. According to rule number 1, if we have this circle, we have here chord AB, This is called AB. That intersects with this chord called CD. This is called CD. So chord AB intersects with chord CD. It's point O. Point O is the intersection point between chord AB and chord CD. This is rule number 1. So if this is the data that has been given to us, then the following equation is true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So write it down. AO times OB equals to CO times OD. We actually can implement rule number 1 in our drawing, because in our drawing we have chord AE that intersects with chord BC at point O, at point D. Again, chord AE intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. Repeat again, chord AE intersects with chord BC at point D, therefore BD times DC equals to AD times DE. Again, BD times DC equals to AD times DE according to rule number 1. So BD is 4, DC is 2, AD is 3, and DE is the missing 9 segments. So actually found out that according to rule number 1, 4 times 2 equals to 3 DE. 4 times 2 is 8. 8 equals to 3 times DE. Here we divide this equation by 3 and we get that according to this equation, DE equals to 8 over 3. DE equals to 8 over 3. So the missing 9 segment, DE equals to 8 over 3 units. In the next step, I present to you rule number 2, and we will implement rule number 2 in our drawing. So if we have this circle, inside this circle we have chord AB. This is chord AB that intersects with chord CD. This is chord CD at 90 degrees. At the intersection point, they create 90 degrees with each other. So all the angles here are equal to 90 degrees. We define the intersection point between chord AB and chord CD as O. The length of side AO equals to A units, the length of side AB OB equals to B units, the length of side CO equals to C units, and the length of side OD equals to D units. Then according to rule number 2, the following equation is true, that 4 times R squared, R is the radius of this circle that contains the two chords. 4r squared equals to a squared plus b squared plus c squared plus d squared. I'll repeat again, if chord AB intersects with chord CD at 90 degrees, then the following equation is true. Those 4 times r squared equals to a squared plus b squared plus c squared plus d squared. Here, r is the radius of this circle that contains the two chords. We can implement rule number 2 in our drawing, because in our drawing we have this circle, inside this circle we have chord AE that intersects with chord BC at 90 degrees. Therefore, according to rule number 2, we get that 4 times r squared equals to bd squared plus dc squared plus ad squared plus de squared. I'll repeat again. 4 times r squared equals to bd squared plus dc squared plus ad squared plus de squared. This is true according to rule number 2, of course. So 4 times r squared equals to bd squared. Bd equals to 4, so bd squared is 4 squared, that is 16, plus dc squared. dc is 2, so dc squared is 2 squared, that is 4, plus ad squared. ad is 3, so ad squared is 3 squared, that is 9, plus de squared. de is 8 over 3, so de squared is 8 over 3 squared, that is 64 over 9. So in conclusion, we found out that 4 times r squared equals to 16 plus 4, that is 20, 20 plus 9 is 29, plus 64 over 9. Here we multiply 29 by 9 and then we divide it by 9 in order to have a common factor with this expression. 29 plus 9 is 261 plus 64 over 9. 261 plus 64 is 325 over 9. So in conclusion, we found out that 4 times r squared equals to 325 over 9. Here we divide this equation by 4 and we get that r squared equals to 325 over 4 times 9 is 36. Okay? $325 is 25 times 13. We substitute 325 by 25 times 13 over 36. Here we take a root out of this equation and we get that r, the radius of the circle that we are looking for, equals to either square root of 25 is 5 over square root of 36 is 6 times square root of 13. It is equal to either 5 over 6 times square root of 13 units, or in terms of numbers it is a little bit greater than 3 units. Okay, so we finish with the second method. The next step I will present to you how to find out the radius of this circle that blocks triangle ABC according to the third method. In the third method, we define angle ABC as theta, and we have a special formula to find out the area of any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. The angle between side AB and side AC is theta. Side AB equals to A units in its length. Side AC equals to B units in its length. Then the area of this triangle ABC will be equal to A times B times sinus theta over 2. I'll repeat again, the area of this triangle ABC will be equal to A times B times sinus theta over 2. We'll implement the new formula to find out the area of our triangle ABC. So according to the new formula, the area of this triangle that is equal to 9 square units, it is equal to AB times BC times sinus theta over 2. Repeat again, the area of this triangle according to the new formula equals to AB times BC times sinus theta over 2. So actually here the area of this triangle equals to 9 square units, and it is equal to AB is 5, BC is 6 times sinus theta over 2. So here, according to equation number 1, 9 equals to 5 times 6 is 30, 30 over 2 is 15, 9 equals to 15 sinus theta. Here we'll divide this equation by 3 and we'll divide equation number 1 by 3 and we'll get that 9 over 3 is 3, so 3 equals to 15 over 3 is 5 times sinus theta. Here we'll divide this equation by 5 and we'll get that according to equation number 1, sinus theta equals to 3/5. Sinus theta equals to 3/5. Actually, we have the trigonometric identity that states that cosine theta equals to the square root of 1 minus sinus square theta. So cosine theta equals to the square root of 1, and we already found out that sinus theta equals to 3/5, therefore sinus square theta will be equal to 3/5 squared, that is actually 3 squared, that is 9, over 5 squared, that is 25. So actually we found out that cosine theta equals to the square root of, here we multiply 1 by 25 and then we will divide it by 25 in order to have a common factor with this expression. So here we will get the 25 minus 9 over 25. So cosine theta equals to 25 minus 9 is 16 over 25. So cosine theta equals to the square root of 16 is 4 over the square root of 25 is 5. So we found out in conclusion that cosine theta equals to 4/5. Cosine theta equals to 4/5. In the next step we will implement the law of cosines in our triangle ABC. What is the law of cosines? I will repeat it on it shortly. The law of cosines is true in any triangle. So if we have a triangle ABC that could be any triangle, this is triangle ABC. The angle between side AB and side AC is theta. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Then according to the law of cosines, we will get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, in this triangle ABC, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. So we will implement the law of cosines in our triangle ABC, and we will get that according to the law of cosines, cosine theta in our triangle ABC, will be equal to AB squared plus BC squared minus AC squared over 2 times AB times BC. Okay? So we already found out that cosine theta equals to 4/5. So we substitute cosine theta by 4/5. That is equal to AB squared. AB is 5, so AB squared is 5 squared, that is 25, plus BC squared. BC is 6, so BC squared is 6 squared, that is 36, minus AC squared over 2 times AB is 5 times BC is 6. Okay? So here we found out that 4/5 equals to 25 plus 36 is 61 minus AC squared over 6 times 5 is 30, and 30 times 2 is 60. So we will multiply this equation by 60, and we will get that 60 times 4 over 5 equals to 61 minus AC squared. Here 60 over 5 is 12, and 12 times 4 is 48. 48 equals to 61 minus AC squared. So here we subtract 48 from this equation, and we will add AC squared simultaneously to this equation. And we will get that AC squared equals to 61 minus 48 is 13. So AC squared equals to 13. We will take out of this equation, and we will get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. So I found out here that AC equals to the square root of 13 units. In the next step, I will present to you a new formula to find out the area of any circle, to find out the radius of any circle that blocks triangle, exactly like in our drawing. So the radius of the circle that blocks triangle ABC, triangle ABC could be any triangle, will be equal to the multiplication of the sides of the triangle that is blocked by the circle. In this case, triangle ABC is blocked by the circles, and the sides of triangle ABC here is AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. In this case, this triangle ABC is blocked by the circle, so it is 4 times the area of triangle ABC. So the radius of this circle, that is the radius that we are looking for, equals to AB. AB is 5 times AC is square root of 13 over BC 6 over 4 times the area of triangle ABC, and it is given us the equation that the area of triangle ABC equals to 9 square units. Okay, so in conclusion, we found out that R, the radius of the circle that we are looking for, it is equal to 5 times 6 is 30 times square root of 13 over 4 times 9 is 36. So here, actually, we found out that the area, that the radius of this circle that blocks triangle ABC equals to 30 times square root of 14 over 36. Here we divide both the numerator and the denominator on this side of the equation by 6, and we get that 30 over 6 is 5, so it is 5 times square root of 13 over 36 over 6 is 6. So in conclusion, we found out that the radius of this circle that blocks triangle ABC equals to either 5 times square root of 13 over 6 units, or in terms of numbers, it is a little bit greater than 3 units. We finish with the first method, with the third method. In the next step, I will summarize the lecture. Okay, we start with the first question. So in the first question, we have this, the big circle. We know that AB is the radius, AB is the diameter of the big circle, and the radius of the big circle equals to 13 units. Inside the triangle ABC is described by the big circle, and triangle ABC also itself blocks the small circle. So the small circle is described by triangle ABC, and the radius of the small circle equals to 4 units, the radius of the big circle equals to 13 units. And we want to find out the area of the blue shape. Okay, so first of all we defined the center of the small circle as O. We defined the point of tendency of tangent CB with the small circle as M. We define the point of tendency of tangent AC with the small circle as N, and we define the point of tendency of tangent AB with the small circle as L. We join points O and M together by a straight line. O is the center of the small circle, M is the point of the small circle itself. Therefore, OM is the radius of the small circle that is equal to 4 units. We join points O and N together by a straight line. O is the center of the small circle, N is the point of the small circle itself. Therefore, ON is the radius of the small circle that is equal to 4 units. So here we have rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent CB with the small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So if CB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius ON that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent CA will be perpendicular to the radius NO. So CA is perpendicular to NO, that is to say this angle equals to 90 degrees, and this angle will also equal to 90 degrees. Then we also have the rule that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So peripheral angle ACB that rests on the diameter of the circle must be equal to 90 degrees. So in quadrilateral ONCM, we have 1, 2, 3 right angles. Okay. repeat again. In quadrilateral ONCM, we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is angle MON. In total, they must be equal to 360 degrees. According to the rule, that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and found out that the missing angle MON equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. So the missing angle, this angle, equals to 90 degrees. It is a right angle. So inside quadrilateral ONCM, we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle. So we relate to quadrilateral ONCM as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle OMCN are equal to each other. They are equal to each other. That is to say, ON equals to CM. Okay, so ON equals to CM. According to the rule, the opposite sides of a rectangle are equal to each other. But we already found out that ON equals to 4 units. It is the radius of the small circle. So here ON equals to 4 units. And from this equation, 4 equals to ON equals to CM. We derive that Cm is also equals to 4 units. Here Cm also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that OM equals to NC. OM equals to NC, but we already found out that OM equals to 4 units. This is the radius of the circle. Here OM equals to 4. And from this equation, 4 equals to OM equals to NC, we derive that NC is also equals to 4 units. Here NC equals to 4 units, so we found out that quadrilateral ONCM is not a rectangle but a square. Then we defined AB as A, CB as B, and AB as C. What is the length of AN? AN equals to AC minus NC. AN equals to AC minus NC, AC equals to A, and C equals to 4, so in conclusion found out that AN equals to A minus 4. Then we found out the length of line segment MB. MB equals to, from the drawing, it is very easy to see that MB equals to CB minus CM. MB equals to CB minus CM, CB equals to B, CM equals to 4, so in conclusion found out that MB equals to B minus 4. Here, MB equals to B minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common exam point to a circle are equal. So if you focus on the common exam point A, we have two tangents to the circle, tangent AL and tangent AN. And according to rule number 2, they must be equal to each other. So here, AN equals to AN according to rule number 2. Okay, AN equals to AN. But here, AN equals to A minus 4. We already found out that AN equals to A minus 4. So from this equation, AN equals to A minus 4, we derive that AN is also equal to A minus 4. AN is also equal to A minus 4. Then we focus on the common exam point B. From the common exam point B, we have two tangents to the circle, tangent BL and tangent BL. And according to rule number 2, they must be equal to each other. Here, PL equals to BM according to rule number 2. But we have already found out that BM equals to B minus 4. So here, BM equals to B minus 4. And from this equation, BL equals to BM equals to B minus 4, we derive that BL is also equals to B minus 4. So we found out that BL equals to minus 4 and AN equals to A minus 4. Okay? Then, according to what is given as the equation, AB is the diameter of the big circle. That is to say, it is equal to 2 times the radius of the big circle. It is given as the equation that the radius of the big circle equals to 13 units. Therefore, the diameter is twice as long. That is to say, the diameter will be equal to 13 times 2 is 26 units. So AB equals to 2 times the radius of the big circle, that is 26 units. So from one side, AB That is the diameter of the big circle equals to 26 units. From the other side, AB according to the drawing, AB equals to AL plus LB. AB equals to AL plus LB. AL equals to A minus 4 and LB equals to B minus 4. AL equals to A minus 4 and LB equals to B minus 4. So in conclusion, we found out that AB that is equal to 26 equals to A plus B plus minus 4 is minus 8. So conclusion found out that according to equation of 1, 26 equals to A plus B minus 8. We added 8 to this equation number 1, and found out that 26 plus 8 is 34. 34 equals to A plus B. We squared both sides of this equation number 1, and we found out that A plus B squared equals to 34 squared. A plus B squared equals to A squared plus B squared plus 2 times AB, and 34 squared equals to 1156. Then we focus on the right triangle ABC according to the Pythagoras theorem on the right triangle ABC. AB squared equals to AC squared plus BC squared. AB squared equals to AC squared plus BC squared. So AB equals to 26. So AB squared is 26 squared, that is 676. So we found out that according to equation number 2, A squared plus B squared equals to 676. That is to say, we can substitute A squared plus B squared in equation number 1 by 676. We did it, and we got that according to equation number 1, A squared plus B squared is 676 plus 2AB equals to 1156. Here we subtracted 676 from this equation number 1, and we found out that 2 times AB equals to 1156 minus 676 is 480. So according to equation number 1, 2 times AB equals to 480. We divided this equation number 1 by 2, and we got that 2 times AB over 2 is AB, so AB equals to 480 over 2. 480 over 2 is 240. So according to equation number 1, we found out that AB equals to 240. We divided the equation number 1 by 2, and we found out that AB over 2 equals to 240 over 2 is 120. So according to equation number 1, AB over 2 equals to 120. And what is the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. Repeat again, the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. The area of triangle ABC equals to the base of the triangle, that is AC, times the height of the base, that is CB over 2. AC times CB over 2, and the area of triangle ABC is pi r square, and r equals to 4 units. Here AC equals to A, CB equals to B. So here AC times CB is A times B, and the area of triangle ABC equals to AC times CB over 2, that is to say it is equal to A times B over 2. Minus the area of the small circle, it is pi r square. R equals to 4 units, so pi r square. So r square is 4 squared, that is 16. So in conclusion, the area of the small circle equals to 16 pi. So the area of the blue shape equals to AB over 2 minus 16 pi. But we have already found out that AB over 2 according to equation number 1 equals to 120, so we can substitute AB over 2 by 120. We did it, and we got that the area of the blue shape equals to 120 minus 16 pi square units, so in terms of numbers it is equal to 69.73 square units. We finished with the first question, then I presented to you the second question, and we solved the second question in 3 different methods. In the second question, we have this circle, and inside this circle we have triangle ABC. Triangle ABC is described by this circle. Side AB of triangle ABC equals to 5 units, side BC equals to 6 units, and the area of this triangle ABC equals to 9 square units, and we want to find out the radius of this circle that blocks triangle ABC. So first of all, we start with the first method. From point A, we draw perpendicular on BC. This angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. So the area of triangle ABC equals to 9 square units. The area of triangle ABC equals to 9 square units according to what is given in the question. And the area of triangle ABC equals to the base of the triangle, that is BC, times the height, that is AD, over 2. So here 9 equals to BC is 6 times AD over 2. 6 over 2 is 3, so 9 equals to 3 times AD. We divided this equation number 1 by 3, and we found out that AD equals to 3 units. Here AD equals to 3 units. Then we focused on the right triangle ABD. We implemented the Pythagoras theorem on the right triangle ABD. According to the Pythagoras theorem, AB square equals to BD square plus AD square. AB square equals to AD square plus BD square. AB is 5, so AB square is 25. Equals to AD square, AD is 3, so AD square is 3 squared, that is 9, plus BD square. We subtracted 9 from this equation number 2, and we found out that 25 minus 9 is 16, so 16 equals to BD square. We took out of this equation number 2, and we found out that BD equals to the square root of 16, that is 4. So BD here equals to 4 units. Then, what is the length of DC? For the domain, it is very easy to say that DC equals to BC minus BD. DC equals to BC minus BD. That is to say, DC equals to BC, that is 6, minus BD, that is 4. So in conclusion, DC equals to 6 minus 4, that is 2. So DC equals to 2 units. Then we focus on the right triangle ADC. We implemented the Pythagoras theorem on this right triangle ADC. According to the Pythagoras theorem, AC square equals to DC square plus AD square. AC square equals to DC square plus AD square. So AC square equals to DC square. DC is 2, so DC square is 2 squared, that is 4, plus AD square. AD is 3, so AD square is 9. So in conclusion, we found out that AC square equals to 4 plus 9, that is 13. So AC square equals to 13. We took out of this equation, and we found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Then we define the center of this circle as O. We joined points A and O together by a straight line. Then we extended the straight line AO by a straight line until it touches the circle at point E. Then we joined points B and D together by a straight line. We created the peripheral angle ABE that rests on the diameter of the circle. AE is the diameter because of the fact that it passes through the center of the circle. And any peripheral angle that rests on the diameter must be equal to 90 degrees. Peripheral angle ABE rests on the diameter, that is AE, therefore ABE. Again, AB equals to 90 degrees according to the rule that I mentioned. Then we have another rule here, that peripheral angles that rest on the same chord are equal to each other. So those two peripheral angles rest on the same chord called AB, therefore they are equal to each other. So here, the peripheral angle ACB equals to peripheral angle AEB. So if we define one angle as theta, then the other angle must be equal also to theta. Then, so this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to 90 degrees minus theta. For the same reason, this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in the right triangle to 180 degrees, this angle must be equal to 90 degrees minus theta. Then we prove that those two right-wing triangles are similar to each other. Why they are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. Those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we prove that all the angles of triangle AB can go into all the angles of triangle ADC, therefore those two triangles can go into each other according to side rule. Okay? And from the fact that those two right triangles can go into each other, we conclude that AB over AD equals to AE over AC. AB over AD equals to AE over AC. AB equals to 5, AD equals to 3, A equals to 2R, it is the diameter of the circle, and AC equals to square root of 13 units. We multiplied this equation number 3 by square root of 13 units, and we found out that the radius of the circle that 2R equals to 5 over 3 times square root of 13 that is equal to 2R. So we divided this equation number 3 by 2 and found out that the radius of this circle equals to either 5 over 6 times square root of 13 units, or in terms of numbers it is a little bit greater than 3 units. So we finished with the first method. Then I presented to you how to find out the radius of this circle according to the second method. In the second method, we use before the things that we already found out in the first method. Here, so from point A we draw perpendicular on BC, so this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then, according to the first method, AD equals to 3 units, DC equals to 2 units, and BD equals to 4 units. Then we extended the straight line AD by straight line until it touches the circle at point E. Then I presented to you rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. You can implement rule number 1 in our drawing, because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, BD times DC equals to AD times DE. Again, BD times DC equals to AD times DE according to rule number 1. BD is 4, DC is 2, AD is 3, and D is the missing line segment. So in conclusion, we found out that 4 times 2 equals to 3 times AD, 4 times 2 is 8, so 8 equals to 3 times DE. We divided this equation by 3 and we found out that DE equals to 8 over 3 units. Then I presented to you rule number 2 and we implemented rule number 2 in our drawing. What is rule number 2? According to rule number 2, if chord AB intersects with chord CD at 90 degrees, then the following equation is true, that 4 times A squared equals to A squared plus B squared plus C squared plus D squared. Okay? So here, in our drawing, we have chord AE that intersects with chord BC at 90 degrees. All the angles around point D are equal to 90 degrees, therefore we can implement rule number 2 in our drawing. According to rule number 2, we'll get that 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. I repeat again, 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. According to rule number 2, so 4 times R squared equals to BD squared. BD is 4, so BD squared is 4 squared, that is 16. DC is 2, so DC squared is 2 squared, that is 4, plus AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus DE squared. D is 8 over 3, so D squared is 16 over 9. So here we got that 4 times A squared equals to 16 plus 4, that is 20, and 20 plus 9 is 29. So 29 plus 64 over 9 equals to 4R squared. Here we multiply 29 by 9 and then we divide it by 9 in order to overcome the factor of this expression. So 29 times 9 is 261 plus 64 over 9. So 261 plus 64 is 329 over 9. So in conclusion, we found out that 4 times R squared equals to 325 over 9. We divided this equation by 4 and we found out that R squared equals to 325 over 4 times 9 is 36. So R squared equals to 325 over 36. We substituted 325 and 25 times 13 and we took a root out of this equation and we found out that R, the radius of the circle that we are looking for, equals to either 5 over 6 times square root of 13 units, so in terms of numbers it is a little bit greater than 3 units. Then I presented to you how to find out the radius of this circle that blocks triangle ABC according to the third method. In the third method, we defined angle ABC as theta. Then I presented to you a new formula to calculate the area of any triangle. If this is triangle ABC, that could be any triangle. Side AB equals to a unit, side AC equals to B units, and the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle ABC equals to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. So we implemented the new formula in order to find out the area of our triangle ABC. According to the new formula, the area of this triangle ABC will be equal to AB times BC times sinus theta over 2. AB times BC times sinus theta over 2. And we know that the area of this triangle ABC equals to 9 square units. So 9 square units equals to AB times BC times sinus theta over 2. AB is 5. BC is 6. So here we found out that 9 equals to 5 times 6 times sinus theta over 2. 9 equals to 5 times 6 is 30, and 30 over 2 is 15. So 9 equals to 15 times sinus theta. We divided this equation number 1 by 3, and we found out that 9 over 3 is 3, so, and 15 over 5 is 5. So 3 equals to 5 times sinus theta. We divided this equation number 1 by 5, and we found out that sinus theta equals to 3/5. Sinus theta equals to 3/5. Then we actually have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. We know that sinus theta equals to 3/5, therefore sinus square theta is 3/5 square. That is 3 squared, that is 9, over 5 squared, that is 25. So cosine theta equals to the square root of 1 minus 9 over 25. We multiplied 1 by 25, and then we divided by 25 in order to overcome the factor with this expression, and we found out that cosine theta equals to 25 minus 9 over 25. 25 minus 9 is 16. So in conclusion, we found out that cosine theta equals to the square root of 16 over 25. So cosine theta equals to the square root of 6, that is 4, over square root of 25, that is 5. So in conclusion, we found out that cosine theta equals to 4/5. Then we implemented the law of cosines in our triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. So if we have this triangle ABC, that would be any triangle, side AB equals to units, side AC equals to B units, and side BC equals to C units, and the angle between side AB and side AC is theta, then cosine theta equals to A square plus B square minus C square over 2 times AB. We implemented the law of cosines in our triangle ABC. According to the law of cosines, cosine theta here will be equal to AB square plus BC square minus AC square over 2 times AB times BC. I'll repeat again. Cosine theta in our triangle will be equal to AB square plus BC square minus AC square over 2 times AB times BC. We have already found out that cosine theta equals to 4/5. AB is 5, so AB square is 5 squared, that is 25. BC is 6, so BC square is 6 squared, that is 36, minus AC square over 2 times AB is 5 and BC is 6. So 4/5 equals to 25 plus 36 is 61, minus AC square over 5 times 6 is 30, and 30 times 2 is 60. So in conclusion, we found out that 4/5 equals to 61 minus AC square over 60. We multiplied this equation by 60, and found out that 4/5 times 60 equals to 61 minus AC square. Here, 60 over 5 is 12, and 12 times 4 is 48. So 48 equals to 61 minus AC square. We subtracted from this equation 48 and added AC square simultaneously, and we found out that AC squared equals to 61 minus 48 is 13. So AC squared equals to 13. We took a root out of this equation and found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Then I presented to you a new formula that by that formula we can find out the radius of any triangle that blocks circle, the radius of any circle that blocks triangle. Exactly like here, we have this circle that blocks triangle ABC. So the radius of this circle that blocks triangle ABC, or the radius of any circle that blocks triangle, it is equal to the multiplication of the sides of the triangle. In this case, it is AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. In this case, it is triangle ABC over 4 times the area of triangle ABC. So it is AB times AC times CB over 4 times the area of triangle ABC. AB is 5, AC is equal to 13, and BC is 6 over 4 times the area of triangle ABC. The area of triangle ABC equals to 9 units, 9 square units, according to what is given as the question. So here we have 5 times square root of 13 times 6 over 4 times the area of triangle ABC is 9 square units. 5 times 6 is 30, so it is in the numerator we have 30 times square root of 13 over 4 times 9 is 36. So R equals to 30 over 36 times square root of 13 units. We divided both the numerator and the denominator of this side of the equation by 6. 30 over 6 is 5, and 36 over 6 is 6. So in conclusion, we found out that the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is equal to a little bit greater than 3 units. So in 3 different methods, we found out that the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, thank you very much.